everybody, it's Miss Campbell, and today we're going to go through the next part of our notes for chapter 15. And today we're going to be looking at building a probability model based on information we're given. And then we're also going to look and see what happens to our mean and the standard deviation when we have independent random variables and we're multiplying or adding stuff to them. So the first thing we have here is on Valentine's Day, the Quiet Nook restaurant offers a Lucky Lovers special that could save couples money on their romantic dinners. When the waiter brings the check, he'll also bring the 4 aces from a deck of cards. And so remember, you have the Ace of Hearts, Ace of Diamonds, clubs, and then spades. Okay, the heart and the diamond, those are red. And then the spade and the club, those are black. So he will shuffle them and lay them down, face down on the table, and then the couple will get to turn one card over. So if it is a black ace, they will owe the full amount. Okay, if it is the Ace of Hearts, then they will, the waiter will give them a $20 discount on it. Okay, if they turn over the Ace of Diamonds, they'll then get to turn over one of the remaining cards. And then if they get the Ace of Hearts that time, they'll get a $10 discount. So what we're going on here is we're going to look, it says based on the probability model for this size of the Lucky Lovers discounts, the restaurant will award what's the expected discount for a couple and what is the standard deviation. So the expected discount is going to be the expected value. Okay, so we're going to have to calculate the expected value there. All right, so okay, so the first thing that we're going to need to do is we're going to need to create our probability distribution. Okay, so we're going to use the capital letter X. Okay, and that's going to be the dollar discount that we're going to get. Okay, so the dollar discount. And you want to label that there so that the graders will know what you are talking about. Okay, and draw your rectangle here. And then we label lowercase x and then P of lowercase x. And then we're going to put the values that we can get. So we could get the $20 discount. We could get the $10 discount. Or you could get a $0 discount. Okay, so now we need to go through and figure these out. So the first thing that you're going to want to do is you're going to want to show the graders where your work is for each of these probabilities. If they cannot tell where your work is, they will not give you credit for that part of it. So you must clearly indicate to them where your work is going to be. So you can draw a little arrow like I have done here, or like you can do it to the side, but you need to clearly label. So I'm going to label over here so you can see, but when in doubt, just put an arrow as well so that they really know what you're talking about. So for X is $20. Okay, so how do we get $20? Well, that's if we draw the Ace of Hearts. So we're looking for the probability of the Ace of Hearts. And how many Ace of Hearts are there? 1. And then how many total cards do we have to choose from? 4. So the probability of getting a $20 discount is 1/4 or 0.25. All right, now $10. So we'll go over here and we'll put X equals 10. Well, how can I get the $10 discount? Well, I have to pull the Ace of Diamonds and then I have to pull the Ace of Hearts, right? So we have to get the probability of the Ace of Hearts, or sorry, Ace of Diamonds, and then also the Ace of Hearts. So Ace of Diamond and Ace of Heart. Okay, and so now we go through here. So how likely are you to pull the Ace of Diamonds? Well, it's still 1 out of 4. Okay, because that's the initial one there. Now, if we pull that out, we're not going to put it back in. So we have to think, oh, okay, now that I've taken that one card out, I now only have 3 cards. So our next probability is going to be out of 3. Okay, and now we're trying to find the hearts, right? The Ace of Hearts. And so how many Ace of Hearts are there? 1. So, and we know that and means that we are multiplying. So we have to multiply here. So 1/4 times 1/3 is 1/12. Okay, and then finally, now what's the probability of getting $0? Okay, so the probability of getting $0, so x equals to 0. Well, that's the probability of getting anything but these other two cards, right? Okay, so let's see here. It's the probability of x equal to 0. So remember, it's going to be 1 minus the probability of the stuff we don't want. So that's when x is greater than 0. Well, what's the probability of x being greater than 0? We have 1 minus, and then it would be the probability of getting the 20 or the 10. So what's the probability of getting a 20? 1/4. And then or means we're going to add. And then the 10 is 1/12. Okay, and you can subtract that there and you can get it as a decimal, but these are simple fractions to work with, so go ahead, get it as a fraction there. So 1/4, make it into twelfths, that will be 3/12, and then another 1/12, so 4/12, right? And then 1 is 12/12, so 12 minus 4 is 8/12. And you can simplify, to 2/3. Don't necessarily have to. It's fine. So we'll just go here. We'll go 2/3. And then what should you do to make sure that you are correct? You should make sure that all three of these add up to 1, okay? So double check that they add up to 1, and then you'll know you got them correct. So there's our probability distribution. Now we have to look and see what's the expected discount. So remember, expected value, that's mu of capital X, and then it's E of X. And remember, write your formula. It's the summation of X sub I times the probability of X sub I. All right, and then we'll go through here and we will show what that's going to be. So we have 20 times 0.25. $10 times 1/12. Okay, and then $0 times 2/3. Okay, so now we'll go on ahead, and what we can do is go in our calculator and we can enter that in. So remember, enter in the 20, the 10, and the 0 into L1, and enter in the 1/4, the 1/12, and the 2/3. And you can type them into the list as fractions into L2, and then do your one variable stats with L1 as the list and L2 as the frequency list, and you will get the mean. And so the mean comes out to be 5.83, and it goes on, dollars. All right, so $5.83 is the mean. So remember, do your writing. In the long run, after many, many trials, right? Okay. The expected discount or the average discount is 5.833. And you can, put a few threes there just as show goes on dollars. Okay, so there you go. That's the mean. Now, standard deviation, your favorite formula. So sigma, remember sigma of x, it's the summation of x sub I minus mu of x squared times the probability of x sub I, and it's the square root of that whole thing there. So now go on and start plugging in. Okay, so we have 20 minus 5.833 squared times 1/4 plus 10 minus 5.833 squared times 1/12 plus 0 minus 5.8333 squared times 2/3. And then square root all of that. And then now again, remember, when you do that one variable stats, it gets you the standard deviation as well, sorry. And that's going to come out to be about $8.62 or so. All right, so that's how we do, a simple introductory one. So now we're going to go ahead and we're going to look at example 4. So it says HEB has a wonderful sale on a dozen of Hill Country Fare extra large eggs. Your grandmother buys a dozen and puts them in your refrigerator. Unfortunately, she didn't check the eggs to see if any were broken. In your carton, 5 of the eggs are broken. You are preparing to make chocolate chip cookies, which requires 2 eggs. So we're going to be picking out 2 eggs. So we're going to create a probability model for the number of broken eggs you could randomly select from your carton. And what is the expected number of broken eggs, and what is that standard deviation? So when we are talking about, we're taking 2 eggs at a time, right? So taking those out there, we could have what, 2 broken eggs? Or we could have 1, or we could have 0, yes? Okay, so we're going to have to figure out the probabilities for each of those situations. Okay, so we'll go ahead and we'll get started on that there. All right, so we're going to go ahead here. We're going to set up our probability distribution. Okay, so we're going to use the random variable capital X, and that's going to be the number of broken eggs. Okay, and we said, so we have the little x, because that's referring to all the little values that x could take on, and the probability of little x. So we could have 0 broken eggs, we could have 1 broken egg, or we could have 2 broken eggs. So now you it doesn't truly matter what order you do these in, but sometimes there's a little bit easier way to do it. Okay, so first thing we're going to look at, I'm going to go ahead and start with 0. What's the probability of getting 0 broken eggs? So we're going to go over here. So we're going to say x equals 0. And so that would be the probability of getting a not broken egg and a not broken. Okay, so now think about this. If 5 of them are broken, that means 7 are not broken. So what's the probability of pulling the first unbroken egg? Well, there's 7 of them out of the 12. And then and means we multiply. Okay, but now think about this. We've taken 1 egg out and it was not broken. Okay, so overall, the number of eggs in the carton has now decreased by 1. And the number of unbroken eggs has decreased by 1 as well. So now our second egg, it has a 6 out of 11 chance of being unbroken. So when you multiply these, you get 42 out of 132. And so you would put that, and again, you can make it a decimal if you like. You could simplify it if you want, but you don't have to. And, sometimes leaving them as the fractions will help you a little bit more in your calculations, just in terms of carrying all the decimals you need. All right, so now we're going to go here for the probability of x equaling to 1. Okay, so x equals to 1. So that would be the probability of getting a what? A broken and an unbroken. Okay, now think about that. If we pull out a broken one first, does that necessarily mean that we're always going to pull out a broken one first? No, we could do it in the other order. So it has to be or unbroken first and then a broken. And we have to consider both orders because if we're taking an egg out, it's going to change the probability of either the broken eggs that are left behind or of the unbroken eggs that are left behind. So you have to consider both options. And since we're doing or, we're going to be calculating the first and one and then the second and one and adding them together. Okay, so that is going to be, all right, so let's say we do the broken one first. Well, we have 5 out of 12 for the first broken one. And then now, again, since we've taken one out, it's 11. but we didn't pick an unbroken one, so there's still 7 of those. So you multiply that and you'll get 35 over 132. Okay. Or, okay, we can go the other way around. Well, unbroken, 7 out of 12. And then we have 5 out of 11, sorry, because there's 5 broken ones. So there were 7 unbroken, and then there's 5 broken, but we had already picked one egg out. So it'll be here. So 7 times 5, again, 35 out of 132. And I know for this one, it doesn't really seem like there's much of a difference, but you do have to show them that you're understanding that it's or, so you're adding them. So don't just show, oh, this times this, and then multiply it by 2. Show them both ways of getting, the 35 out of 132 so that they understand that you know what you're doing. And so then we have 35 out of 132 plus 35 out of 132. So we add that, so it's 70 out of 132. And go add it here, 70 out of 132. All right, cool. Now, the next one, what's the probability of getting 2 broken eggs? Okay, so if we get 2 broken eggs, well, that's a probability of a broken and a broken. Okay, a broken and a broken. So again, first one, broken eggs, 5 out of 12. Okay, now our second one, there's only 11 eggs, and we already took 1 broken, so that means now we only have 4 broken ones. So 5 times 4 will be 20. 20 out of 132. And so there you go, 20 out of 132. Okay, there is another way that you can think of getting for x equals to 1. Okay, you can always do the probability of x being exactly 1. Could be 1 minus the probability of x being equal to 0 or x being equal to 2. Okay, so you can do it like that too, if that seems more natural to you. And sometimes, just working through these problems a lot and practicing with it, that's kind of what helps you decide what you feel more comfortable with, what order you like to work in. Alrighty, so that's just, simple going on and setting up a probability model based on a situation you're given. Okay, so what you can do now with that is you can try to start working on the back of the bunco activity sheet and try to see if you can come up and figure out the probabilities of winning, the different amounts of money. So figure out those theoretical probabilities, and we'll look at those together when I'll be there next. So let's go here now. This one, we're looking at we're being given independent random variables, okay, with the means and the standard deviations shown, and we need to find the mean and standard deviation of each of these variables, okay? So we have 0.8 y, so 0.8 times y, 2 times x minus 100 from it, x plus 2y, 3x minus y, and y1 plus y2. All right, so we're going to go through how to do all of these here. And we have looked at these rules before. If you remember, a few chapters ago, we looked at what happens when you multiply the means and the standard deviations, what happens when you add numbers to the mean or to the standard deviation. And we saw which ones were affected by multiplying or by adding, subtracting. So first one we'll look at here, 0.8y, okay? 0.8y. So we'll go and we'll fill in our formulas on the first page. So go to the very first page of your packet. Okay. And we see here we have the, so it says changing a random variable by a constant. Okay, so this is going to be, the first one's either adding or subtracting something to it. And the next thing we'll look at is by multiplying it. Okay, so the first one, the expected value of x plus or minus some constant c, well, it's just the expected value of x, and then you add or subtract whatever c is. Because the mean, it is affected by adding or subtracting. Okay, now this one here I know says variance, but we're going to say it's the standard deviation of x plus or minus some constant c. Okay, your standard deviation is not going to get wider or smaller Yeah, like wider or more narrow based on just you moving the data. We're just shifting the data up. So our standard deviation, that width away from the mean is not going to change. So if you're just adding or subtracting to your random variable, then your standard deviation is still just going to be the same. It's just going to be a standard deviation of x. All right, now for multiplying. So if we have the expected value of some amount a times our variable x, well, mean it gets multiplied. So it's a times the expected value of x. And then now again, standard deviation. Okay, so the standard deviation of some a times x, that is going to change because we are multiplying the width, right? So we're multiplying the mean, and so that means that we're like stretching our data out or making it more narrow. And so that one is actually going to change our standard deviation, and it's just by multiplying. So you multiply your standard deviation by that factor, whatever they're saying to do. Okay, so now let's go here and we will go over this one. All right, so 0.8 times y. 0.8 times y. So we see here y, our mean is 300 and our standard deviation is 16. So the mean, all right, the mean, the expected value of y, so 0.8y is just 0.8 times 300, which if you put that in your calculator, you will get 240. And then now the standard deviation, so the standard deviation of 0.8y is 0.8 times, and the standard deviation for y is 16. So 0.8 times 16, and you will get 12.8. So that one, good, nice, and straightforward. Okay, so nice and straightforward. Now we're going to look here at B. We're going to do 2 times our x and then subtract 100 from it. So again, we know that the expected value of 2x minus 100, well, we're going to do 2 times the expected value of x. And then we're going to go ahead and we're going to subtract 100 from it. So 2 times 120 minus 100. So you will get, so this is going to be equal to 140. All right, and then standard deviation. Now from here, the standard deviation of 2x minus 100, well, only the multiplying is going to affect it. So it's just going to be 2 times the standard deviation of x, which is 12. So it's 24. Okay, so those are nice, straightforward. And if you see here in example A and B, we're only dealing with like y by itself or x by itself. Now we're going to go and look at some other cases where we are combining random variables. So if you see on example C, we have x plus 2y. And so now when we're combining multiple different independent random variables, we have to look at how those work together. So we're going to come way back up here to the front. Okay, so when we are adding or subtracting random variables, we are going to be using what is called the Pythagorean theorem of statistics. Okay, the Pythagorean theorem of statistics. And so basically, we have here, okay, if you like the means, straightforward. Okay, if you're doing the absolute value of the variable x plus or minus the variable y, well, it's just not the absolute value, I'm sorry, guys, the expected value of x plus or minus the expected value of y. Okay, so the means are straightforward. You just add them or you subtract them. Okay, and then now variance, we're going to come back to that here in a second. So you see how we say Pythagorean theorem of statistics, right? Okay, so your variance is sigma squared, right? So you have sigma squared of x plus y, okay? So start off with that one, x plus y. So that will be the variance of x squared. So the standard deviation x squared, so it's sigma squared, okay? Plus the variance of y. So remember, variance is sigma squared. All right. But now, y'all, we want to get just the standard deviation. So we have to do the square root there. Okay. So the variance is the standard deviation squared. So if I just want the variance of x plus y, well, it's going to give me the square root of the variance of x plus the variance of y. And so this looks a whole lot like the Pythagorean theorem. Okay. And that's actually kind of what it's based on there. So whenever you have two independent variables, okay, the variance for them, all right, is just going to be variance of x plus y. Okay, it's the variance of x plus square. Yeah, so the variance of x and then the variance of y. So remember, variance is standard deviation squared. So sigma squared is your variance. All right. So now here, when we have the standard deviation of x plus or minus y, well, if you look right here, we see it's going to be the variance of x plus the variance of y and square root all that. Okay, because when you are trying to find distances between things, you square them, so we get rid of the negatives, right? So even if we're taking so this is right here, this is always going to be positive. Okay, so it's always positive. Okay, and remember, standard deviation is trying to find out how far away from the mean we generally are. So even if you are doing x plus y, or the standard deviation of x minus y, it's always going to be the variance of x squared plus the variance of y squared. Okay, so this is just your formula there. So now we'll go on ahead and we'll go back and look at our examples. Okay, so we have x plus 2y. Well, okay. Sorry for my running out of room here. So we have the expected value of x plus 2y. Okay, x plus 2y. That's going to be 2. It's just going to be the expected value of x plus 2 times the expected value of y. So expected value of x is 120. And then 2 times the expected value of y. So 2 times 300. So it's going to be 700. All right, cool. Now, the standard deviation of them. Okay, remember, it doesn't matter if you're adding x or y or if you're subtracting x or y. We're always going to be doing the sum of their variances. And remember, the variance is the standard deviation squared. So, sigma of x plus 2y, and these are capital X and capital Y. All right, it's the square root of the standard deviation of x squared plus the standard deviation of 2y squared. Okay, so 2y squared. And remember, the standard deviation of 2y, well, that gets multiplied by 2. So we have the square root of 12. So x is just the same. So it's 12 squared. And then since it's 2y, remember, standard deviation is affected by multiplication. So you have to multiply this by 2. So it's 16 right now. So times 2, it'll be 32 squared. And if you put this in your calculator, you will come out with about 34.176-ish in there. All right. So remember, standard deviation is still affected by the multiplying. Okay, still affected by the multiplying. But now whenever we're like finding the standard deviation of the combination of the variables, we're using this Pythagorean theorem of statistics. All right, now here. All right, 3 times x minus y. So we have the expected value of 3x. Well, that's 3 times 120. And so that comes out to be 360. Okay. And then we just have minus y. All right. So it's just going to still be the expected value of y. So here we have the mu, all right, is going to be mu of 3x minus y. We're going to do 360, which is the expected value for our 3x, minus, and then we have our expected value for y, which is 300. So 360 minus 300 is 60, okay? And so that's going to be your mean of 3x minus y. Sorry, minus y. Okay, now standard deviation. Okay, I know it says 3x minus y. Well, first go figure out the standard deviation of 3x. Okay, of 3x. Remember, standard deviation is affected by multiplication. So it's 12 times 3. So that one's 36. And now again, we're subtracting. Standard deviation doesn't care. So the standard deviation of 3x minus y equals square root, and remember, we're going to have the standard deviation of 3x squared, so that would be 36 squared, plus, it's always plus, and then we would have the standard deviation of y squared, so 16 squared. All right, and that will come out to be 39.395. Okay, and that would be your standard deviation of 3x minus y. All right, and then one last one here. One last one. And this is going to be here, y1 plus y2. Okay, y'all, y1 plus y2. This is y happening twice. Y happening twice. Okay, now you have to be careful. If they're saying that, some variable is happening, you're doing it like 10 times, you're doing it 20 times, whatever that is, right? You cannot just go and say, oh, it's y times 2. It doesn't quite always work like that. So whenever you're seeing here, like that you are repeatedly going through a couple variables here, the same variable multiple times, don't just go multiply it. You have to actually write it out. Okay, so for the mean for this, it would be the mean of y1 plus y2. Okay, and so just adding them, you're just gonna, like whenever you're adding independent random variables, you just add their means. So 300 plus 300. So that is 600. Okay, so that's the mean of that, y1 plus y2. And now the standard deviation, again, standard deviation of y1 plus y2 is the square root, and it will be their standard deviations squared. So the standard deviation of y is 16 squared plus 16 squared. And when you do that, you will get about 22.627-ish in there. Okay, so I think we'll stop there for today because you do have some other things that you need to get to. And a copy of these notes will be posted on Blackboard for you guys to see. And so what I would like for you to do is, number one, finish the multiple choice from the chapter 14 packet, the one that we have been working on previously. So that packet should be completely finished by the time I see you Monday. And then the chapter 15 packet, that one, you can start working on it. You should be able to do most of it, at least the first 3 sheets of it, front and back, because the first sheet is the bunco, and then you can do the next 2 sheets of practice problems there. So you have everything you need for doing those. And also do not forget, you need to complete the AP Classroom because it's due in class. So just to let you guys know, and I will see you all on Monday. And of course, if you have questions, please come see me in office hours so that you won't get left behind. All right, y'all have a great weekend. See you Monday.